Okay, for numbers 10 through 12, it says to write each expression as a single logarithm. And for what we have for number 10, we have 2 times the base 5 logarithm of 10 plus 3 times the base 5 logarithm of x minus 2 times, the base 5 logarithm of y. Okay, so again, just reverting back to our previous properties when we were looking at expanding logarithmic terms. Okay, and again, we have these two properties. You have ways upon which, you can have expansion to result from the compressed terms. And again, the equations happen to work in both directions. So we can go from compressing to expanding and vice versa. Now, for what we have in trying to make these three terms into a single base 5 logarithm, okay, so any coefficients I have at the front, I can rewrite as exponents. Okay, so the first term, this is going to become where we had the transition going from 2 base 5 logarithm of 10 to the base 5 logarithm of 10 to the second. And then we have next, we're going to have plus the base 5 logarithm of x to the third. And we have minus the base 5 logarithm of what is going to be y to the second. And putting it together as a single base 5 logarithmic term. Again, so anything that is positive, the attachment goes to the top. So we have 10 squared at the top. Since the next term we have to be added, we have x cubed at the top. And since the last term is subtracted, we're going to have y squared at the bottom. And just for the official final result, okay, now 10 squared has a numerical value. And we have just for the official final result, we're going to have the base 5 logarithm of 100 x cubed all over y to the second. For number 11, okay, so I have 2 times the natural logarithm of u plus 3 times the natural logarithm of v plus 1/2 the natural logarithm of the quantity of u plus v minus 3/4 of the natural logarithm of the quantity of w to the fourth plus y to the fifth minus z. Okay, so going from expanded to compressed. Okay, so 2 times the natural logarithm of u. Again, I'm going to treat the 2 as an exponent, so I have the natural logarithm of u squared. Next term, 3 becomes a power. We're going to have the natural logarithm of v to the third. 1/2 likewise, we're going to have the natural logarithm of the quantity of u plus v raised to the 1/2. And with the last term, okay, we're going to have minus the natural logarithm. And this particular 3-term expression is going to be raised to the 3/4 power. Okay, so I have the natural logarithm of the quantity of w to the fourth plus y to the fifth minus z raised to the 3/4. And with the coefficients out of the way, I can now write as a single natural logarithmic term. Okay, and anything that involves addition, okay, the attachments will go at the top. So we have a positive natural logarithmic term with u squared, so u squared goes to the top. Next term is positive, so v cubed is at the top. Third term is positive, so we have the quantity of u plus v to the 1/2. This will go to the top. And since the last term is subtracted, we're going to have the quantity of w to the fourth plus y to the fifth minus z raised to the 3/4 is going to go to the bottom. And this will be the final result for what we have in this single natural logarithmic term. For what I have in the case of number 12, I have 12 times the base 5 logarithm of the cubic root of y minus 4. And I have plus 2 times, okay, the base 5 logarithm of the quantity of y squared plus 15 minus 5 times the base 5 logarithm of the cubic root of y plus 5. Now, in the written work, I have rewritten the radicals as non-integer powers. And so just looking at what we have in the makeup, okay, so we have 12 times the base 5 logarithm, and we have of the quantity y minus 4 to the 1/3, and I have plus 2 times the base 5 logarithm of the quantity of y squared plus 15, and I have minus the base 5 logarithm of the quantity of y plus 5 raised to the 1/3. And treating the coefficients as exponents. So what's going to happen here, first term, now I have the base 5 logarithm, and I have y minus 4 raised to the 1/3. And this is going to further be raised to the 12th power. And the second term, I'm going to have plus the base 5 logarithm of the quantity of y squared plus 15. And this will be raised to the second. And again, I have minus the base 5 logarithm of the quantity of y plus 5 raised to the 1/3. Okay, and now we had to apply a little bit more work, okay, to the first term. So you had the base 5 logarithm of what is going to be y minus 4, and to the 1/3 to the 12th. Okay, so we're looking at the power property of exponents. If you have a base to a power raised to another power, the powers will multiply each other out. So 1/3 of 12 is going to be 4. And again, so you had the base 5 logarithm of the quantity of y minus 4 raised to the 4th. I have plus the base 5 logarithm of the quantity of y squared plus 15 raised to the second. And again, I have minus the base 5 logarithm of the quantity of y plus 5 raised to the 1/3. Okay, and so just making as a single base 5 logarithmic term. So we had the base 5 logarithm. And here we want to have y minus 4 raised to the 4th. Next term is positive, so y squared plus 15. Quantity squared will go at the top. And since the last term is subtracted, the attachment, whereupon we have y plus 5 to the 1/3. Okay, this will go on the bottom. And this will be the resulting base 5 logarithmic term when written as a single expression.